Okay, good evening. Thank you all for showing up for the last session of the day. We appreciate you being here. I'm Amy Wheelis with AT&T. I'm VP of, what am I VP of? No, I'm just joking. I am VP of Cloud and D2 Integration at AT&T, and I'm happy to have my cloud development leadership team here with me to talk about the anatomy of our network cloud and what we think a network cloud is about. I've got Ryan Van Veek and Andrew Lesick here with me, and they'll come up in a little bit and talk more about it. I'm going to start us off by talking about the path to the network cloud. How did we get here? Where have we been and how did we get here? Ryan will then talk about the network cloud design. Andrew will talk about network cloud delivery, and then Ryan will close us up and wrap us up with what's next. Before I get into our path to network cloud, I want to point something out on the slides. And if you've been to any of the AT&T presentations throughout the summit, you'll see at the top there are three words there: security, containerization, and quality. Everything that we've been presenting on and doing talks on at the summit has been around either security, containerization, or quality, or all three. And that is the focus areas that we feel are important for us and important for OpenStack as we move forward and the community moves forward. And so we wanted to point that out. Today we're talking about containerization, but also we'll talk some about quality, and security is our top priority in our network cloud. So what are our business drivers? Why do we need a network cloud? Why do we need a network cloud that is highly secure, highly reliable, and that can operate very predictably? Well, FirstNet. We talked in Sydney in the keynote about FirstNet and our first responder network that is utilizing our cloud today. Our Intelligent Edge suite of products, Network on Demand was the first one of those that used our cloud. SD-WAN is the latest one. Those Intelligent Edge products need our cloud and are using it. Business Collaboration, AT&T Collaborate is a product that uses, that rides on our cloud. Virtual EPC, the virtual packet core for mobility applications, that is using our cloud. Cricket Wireless has applications on our cloud. And then the use case that will be the one that is the one we announced as the first use case for our utilizing Airship is 5G, and that will be the first iteration of our evolved cloud that is called Network Cloud. I'm going to take you back a little bit in history. We talked about the types of products and the types of services that we're using on our cloud. This has been a journey over the past 4+ years. We started out with a vision that was going to converge all of our clouds that were within AT&T into a single AT&T integrated cloud. And that's where we started. We created a common platform, a common architecture. We used structured agile development methodology. We unified our code base. And we had global automated deployments of our cloud. You see the version numbers up there, AIC 1.0 through AIC 2.5. In the last year, we continued to evolve that with our AIC 3.0 release. We added host profiles and flavor series. We added more fault tolerance. We added some normalization around our hardware and our architecture there. We made it more resilient, and we matured our security. This year, we're evolving that even more, and that's what I was talking about our network cloud. And network cloud is the evolution of AIC. In some of the other talks, we've had some questions about, is Airship the same thing as AIC? Is network cloud the same thing as AIC? It is the evolution of AIC. AIC exists in our network. We have live workloads on it. We're operating it there. We will continue to do that. And we are putting Network Cloud, our first release of that, will be utilized for our 5G core workloads. What is that structure? What is that architecture? Ryan's going to get into it in more detail, but it's container-based. It's It's the Airship under cloud platform that we've talked about earlier in the conference. It is a Lego blocked infrastructure. It is highly repeatable, highly predictable. It's a scalable footprint, very high performance focused. We're making this name change not just to have a name change. It's very intentional. We are focused on optimizing our cloud for our network workloads and optimizing it for those types of network workloads that a traditional telecommunications provider or that somebody that is providing workloads for ultra low latency types of applications that come with the 5G capabilities that'll come are. The other thing that we're doing is, OwnApp will be the orchestration vehicle for those VNFs that are riding on our cloud. eComp, started within AT&T, and we took that open into ONAP. And we did that by taking 8.5 million lines of code and contributing that out into open source and creating OwnApp. It's eComp and then a couple of other platforms that have come together to create OwnApp. There are over 900 contributors to date. There are over 50 members and over 30 projects that are associated with OwnApp. And it will become, we will continue to use that and host that. We host it today on AIC. We will host it on our network cloud as we move forward. The other thing that we're doing is both Airship and the work we're doing in our network cloud and OwnApp are components that will be part of our Acrano Edge Stack that you've also heard talks about and seen the project. In fact, later tonight, there's I think an event, an Acrano event. There was an Acrano event last week as well. We are working hand in hand with the Acrano community to work together to make Airship and OwnApp work together and help create that edge stack. With that, let me turn it over to Ryan and let Ryan talk about this network cloud design in a little more detail.
Thank you, Amy. All right, so Amy said the word evolve a couple times. That's pretty important. We've been doing this now for about 4.5 years, and it's been 4.5 years of real world scale and experience, right? And we didn't kind of wade into the shallow end. We went all in, and within our first year, had built 70 production environments around the world. And so when you do something like that, you move fast, you learn a lot really quickly. And so we kind of stepped back about a year ago and said, if we were to do some of these things again and we had an opportunity to do things differently, how would we do that? How would we incorporate all of the learnings that we've had over the past 4 years? And that was kind of the genesis of what our network cloud next evolutionary step is. And so we focus on 3 main buckets. What would we do in the speed space? What would we do in the cost space? And what would we do in the quality space? When it comes to speed, this is kind of the easy bucket to talk about because everybody has this pressure when you're talking about doing things at scale. We need to be able to do our software deployments much faster than we do today. We need to be able to upgrade our environments much quicker than we do today, and we need to be able to push minor upgrades on a semi-frequent basis. Those all kind of laying the foundation for a continuous delivery in a large-scale cloud environment. The next element of that is to be able to do that without impact. And those two things go together, and sometimes that's not really well understood, but if you've got a very large footprint and every time you make a change, there's a large impact, that means your tenant base or your customer base that's running in that cloud environment doesn't let you make changes, right? And that slows you down, so you have an anchor essentially hanging around your neck. So if you want to go fast, you have to solve both. You need to be able to deliver the software fast, but you also need to be able to do it without impacting your tenants. And otherwise, you can't solve that equation. So that's a key driver as we move forward, is being able to do upgrades without impacting our running workloads. And then all of this, like I said, is laying that foundation as we move forward towards a continuous delivery type of environment. And we start that on the left. So we start that in our dev and test environments, and being able to reset our infrastructure environments very, very quickly. So rather than kind of a traditional model where you build your software for your cloud infrastructure, you go through the deployment methodologies like you would in production, stand up sites, and then you validate. That's slow, right? We need to be able to do that in a matter of hours, do it fully automated, and do it, across a number of reference architectures. So that was another driver as well. Lowering cost. Really, this was more about how do we make better use of the equipment that we have, right? So rather than dedicating a set of racks to control plane, how do we essentially just label infrastructure going forward so that any host can perform any role? That would allow us to better utilize our resources, because as we needed to scale environments, we wouldn't have to buy big blocks of control infrastructure anymore. We needed flexibility, because today, in our 3.0 environment, although we moved to virtualization of our control plane, we're still rigid, right? Because of VMs, you can't just create a VM for every service that you want on that control plane host because of the overhead involved. As we move to containerization, now we have that flexibility where every service can live inside its own container. We've got that fine-grained control going forward where we can mix and max what we need to put on that host. That's something that we didn't have before. And finally, when it comes to quality, the key word here is predictability, right? We need to be able to prove to our operations teams, and it goes back to the connection with CI/CD, we need to be able to prove that we can do this action every time with the same outcome, right? I think any operator that's in this room will understand this, that when you have many locations, being able to say that I'm doing an upgrade and every single location will have exactly the same experience and completely 100% predictable, that's not reality, right? It's just not real today. And we need to solve that equation. Otherwise, again, we can't get to that speed and we can't get to that full automation through CI/CD. We want the machine to be able to drive our deployments in the future. And until we can prove that we can do them predictably everywhere, we're never going to get there. So that's a key element. And then goes hand in hand with that is operational excellence in terms of building in resiliency natively and greater control, higher visibility, and all those good things. So what did we do? So Amy mentioned it. We've talked about it a lot this week, and there's a number of conversations tomorrow as well, a number of talks tomorrow. We created what we're calling Airship. Essentially, it's a new OpenStack open infrastructure project. The goal here is to be able to solve for those dimensions I mentioned on the prior slide. And the initial focus is essentially OpenStack on Kubernetes, but it's not OpenStack-centric. Our cloud is OpenStack at its core, but any large operator has many more things involved in OpenStack to make it work. And so, the things that we're using to instantiate our cloud need to be treated the same way. So it was a major driver for us was, how do we get to one workflow for delivering our cloud infrastructure regardless of what that is? So if it's Kubernetes, for example, the way we deliver Kubernetes, which is the foundation of our new platform, should be delivered the same way we deliver the things that ride on top of Kubernetes. And that's critical, because today we have different workflows for different types of functions. We have a workflow for doing operational fixes, we have a workflow for doing major upgrades, we have a workflow to do greenfield deployments. All of those different workflows have different elements of automation, requires segmenting your development teams, stretches your resources, and again, attacks that challenge, it creates that challenge of predictability. So getting to one workflow was a critical thing, and Airship allows us to do that. Because not only does Airship facilitate that, but it uses it as well. So it consumes the processes that it lays out. It's declarative, it's container-based, and when we say container-based, our rule for the platform is everything is a container, everything. There's no exceptions. And then it allows us to be architecturally flexible. I mentioned this in that you're not only solving for OpenStack, we're solving for OpenStack++, right? Whatever else you need. I'm not going to go through all the components. We've had a number of talks on it this week, but essentially we've got a collection of nautically themed microservices. Each one is designed to do the job that it does and do that job really well and no more, right? So we didn't want to create this monolithic platform that's an inhibitor to adoption. We wanted to create specific functions that need to be done in order to stand up cloud infrastructure and allow other operators to kind of pick and choose a best of breed, right? And so we believe that the right answer is the whole, but we wanted to enable folks to pick and choose. And one of our partners from the beginning, SKT Telecom, they've been using Armada to do their container infrastructure deployment, and they just picked that one project as well as OpenStack Helm to help them do that. So just to wrap up, what does this thing look like when you put the pieces together? Essentially, we've taken Airship and kind of layered it into our cloud infrastructure. It forms what we call the foundation of our cloud or our under cloud platform. It's all the blue components themselves, that's Airship. And then the green is what it works with. What are those other open source components that it works with to make that reality? The one thing I did mention on the other slide that I don't want to forget about is Ceph. Ceph is a critical element of what we're doing here in that it allows us to create a self-contained control plane, right? Today, we have a virtualized control plane that relies on external storage. That's a challenge because now a developer who wants to have the same experience with that platform can't do that because he can't have a lab with a multi-million-dollar array sitting in it, right? So if you want to give him the same experience, you got to give him the same storage, and Ceph allows us to do that. It allows us to shift left because it allows us to shift our platform to our VNF vendors that want to test against our platform because we can give them everything that they need to do their work. And that is going to be very powerful, again, in driving that speed equation. And with that, I'm going to hand it over to Andrew, who's going to talk about how we do this.
Thank you. Thank you, Ryan. Yeah, so we thank you guys both for leading into that. That was good. So when we were pulling this together, we wanted to distill it down to a few different things that we've learned over the last few years of how we were going to approach the new generation of network cloud. And learning was really key to how we got here and what we've been able to achieve. And we've done quite a bit of thinking on how we approach these problems. And so simplicity, predictability, and quality are the three things, if we were to say from AIC 1 to 2 and then to 3, that we've incrementally tried to improve on. It's to drive to these things, and these are the actual inhibitors of that are driving the change. Since we weren't able to achieve the simplicity we desired and the predictability and the quality, we were able to go back to the drawing board and identify what are those things preventing us from achieving that. And you know, from a knowledge standpoint, from a team, you know, in 2015 we were new to the technology stack, to the technology stack itself. Those were, you know, preventing us from achieving these things. And we didn't really understand how to approach scaled cloud engineering. In 2015, I think we had 3 clouds whenever I first took on the job. And then, you know, by May, I think we were told that we were going to deliver 100 clouds or so into production. So that opened our eyes, and we started realizing, well, you know, we can't reinvent the wheel on things, so what can we do? And we started laying out some really important delivery principles and around reuse and leveraging best-in-class products and partnerships to help us achieve success, and set our sights on ultimately where we've landed now. And the evolution of the CNCF Foundation and their suite of tools, along with where OpenStack has grown, we're able to kind of pull these 2 best-in-class open source projects together into a single solution, and really achieve what that slide that Ryan was sharing with you. You could probably go back to a lot of the material we set out in 2015 with the vision of what we were trying to achieve with hitless upgrades and rapid deployments and scale deployments. We just weren't ready, and I don't think the technologies are ready for achieving that. That's where we're at today, though, with Airship and what we've been able to deploy in our first 5EC lab or 5G lab. Some of the interesting things we're doing here is introducing some standalone components within our Airship, and the Keystone and Barbican using these things as standalone services has been really important to where we'd like to go to. Instead of thinking of these as blocks that have to go together in a chain, we would like to separate these and use these independently, and it's something we've worked on and continue to contribute to, and something we've achieved. OpenStack Helm, obviously everybody's aware of that and our commitment to that, and that's gotten us to sort of where we're at now. So some of the more interesting things of where we're trying to get to was our predictability, and the predictability is started at our automation and our CI/CD pipelines. On the previous slide, we wanted to get to something that we could deploy over and over again, and in our previous iterations, what we stumble upon a lot is the length of time it would take for us to deploy a reference architecture, and having what Ryan said, storage arrays and a lot of the other variables. Individuals were not able to do that on a smaller scale, so being able to kind of shrink wrap that into, you've heard people talk about Airship in a bottle if you went to the keynote and went to any of our conversations, being able to deploy that on a local development environment and then promote that using all the exact same mechanisms all the way through our pipelines, where on the left side of this pipeline here is just kind of showing you the CI and the CD from a continuous delivery standpoint, where we produce the image artifacts, putting those in the repository and having everything event-based. We've eliminated the human factor out of the deployment completely. And that's something we had never been able to achieve in our virtual sort of infrastructure, our previous iteration. Another thing that we did very early on is make sure that we had consistency in everything we did. Airship is something that runs, or our undercloud is something that runs under everything we deploy, including our artifact repositories, our CI/CD, everything runs on that. So no matter what we deploy in the network cloud infrastructure for the AT&T deployments will all run under Airship, or will run on top of Airship. So yeah, it's kind of touched on no-touch deployments. So that's the predictability nature of it, that we can do it constantly from development all the way through our labs. Finally, something that is really important to us is driving quality into our products. It's something that we've defined as the Aqua framework, and really that's just glue around sanctioned frameworks or best-in-class frameworks again. We're a very principle-driven software organization, so we're agile at heart, but the principles, and you kind of keep hearing about a lot of these things from a theme, is just flexibility and predictability. But when you get down to the engineering principles, we're really disciplined at that, and our focus is on identifying areas of opportunity to always eliminate the human factor out of what we do, introduce extremely robust quality engineering, and that's what kind of came out of this Aqua framework. And this was kind of lessons learned from 2015 and 2016, was we had to evolve our test automation and reduce the sort of late impacts that we've continually had deploying sites, and move all that to the left. To the right, you'll see all the different dimensions that we've focused on evolving. The frameworks underneath of these are things like Tempest and Shaker and other test frameworks that people say, but we're just trying to make them, add a layer of intelligence on them, containerize them, add a layer of intelligence on them, and like being able to self-assess an environment and before education. And that would be it for that. Thanks, Ryan.
Thanks, Andrew. All right, so what's next? So Andrew made mention to it, but we've begun our network cloud deployments leveraging Airship at its foundation. That started in April. We're in test phase on that platform right now with 5G workloads. Moving forward to the fourth Q of this year, we intend to start being ready to move our new platform into production environments and be ready for that. And that's timed, obviously, with our market launch for 5G, where we're rolling out those initial markets. So what does that mean from an Airship milestone perspective? Well, we'll have a fairly large scale telco cloud running on this platform at the end of this year, and that's hard to do. We have a lot of challenges between now and then, but we don't have a choice. We have to get there. So we will get there, and we would love to get there together, right? So there's a lot of opportunity on that project to come in and collaborate, whether it's at the OpenStack Helm level and helping to contribute charts in that space, helping with documentation to mature this thing and make it production ready, or in the Airship space, whether it is to come in and start just using some of those components and to provide feedback to us in the community. That would be fantastic to help us get there faster. This week, there's been a number of talks related to this. They're listed here. So if you missed some of them and you're interested, I encourage you to go back and look at the videos for that. Reach out to us directly if you want to talk about it. We're happy to talk to anybody, anytime. One of the things that we're very proud of is that this has been born in the open. We started working on it a year ago with SKT and Intel and others, and everything here is 100% open. The only thing that is not public is our internal site YAMLs that define our implementations at those specific locations. There's not a single line of code that is being held back by AT&T. So the code that is being contributed this week to OpenStack is our code. That's our platform. So feel free to take a look and kick the tires and jump in, hopefully. Questions? Sunil, I know this gentleman.
Go to the microphone.
So great presentation, and congratulations to AT&T and you guys for doing what you're doing. It's really great. So everything moving to containers, as in network cloud, what do you plan, or what is your view on security?
So I'll take that. Security is number one. One of the things that we're doing with respect to how we implement with Airship is really thinking about that as from a by design principle, right? So we're not caring for security at the end. We're thinking about it day one, and again, that's based on real world learnings. Amy mentioned that part of 3.0 was securing our platform, hardening our platform. Well, we're not forgetting that. We're taking that from our production deployments and applying that day one in the platform, thinking about that from the ground up. One of the reasons we've started with the control plane as where we containerize versus jumping into trying to containerize workloads themselves and VNFs is because of the control plane is one tenant, right? It's a trusted tenant. You can trust those services, and so that kind of helps us solve for some of the challenges in the container space with respect to security, and that's a secure, trusted space. But yeah, I mean, lots of work to do in that space, but it's being done from day one.
Something else we're doing in that space is obviously automating every one of the test areas as well, from static code analysis to some of the other frameworks that our CSO partners suggest that we have in place for penetration testing and database testing. All that gets integrated early in the development cycle and make sure that we're catching vulnerabilities early in the process and building, pipelines around that. And those are all quality gates now as part of the Aqua security framework.
Other questions?
Hi.
Hi.
Thanks. Just a couple of clarifier questions, I guess. I noticed on a couple of slides a reference to Calico, I guess, from a networking point of view, if I'm right. And then here there's also a mention of Open Contrail. And I'm just wondering about the relationship of those.
So Calico is the CNI that we're using for Kubernetes.
Okay.
For the undercloud platform.
Yeah.
And we are using Contrail within it's our SDN within OpenStack.
Okay, I got it. Yeah.
So.
And the second one is, I'm guessing that this means all of your VNFs are coming as containerized.
That would be a bad assumption.
Yeah.
Not yet.
Yeah. And that goes back to what I talked about. I think to answer that question maybe a little differently, one of the biggest benefits we see for containerization is some of the native resiliency that comes out of the box with Kubernetes, right? And the orchestration that you can do with that. A lot of VNFs today in their current state rely heavily on pinning to physical resources, right? And so those two worlds just don't work well together, right? So if you're containerizing a VNF for the sake of containerizing a VNF, but you're not willing to take advantage of all those native capabilities out of Kubernetes, there's kind of an issue there, right? And so we believe there's opportunities there, and VNFs can be split apart. And there's things that control plane versus data plane and things like that,
right.
And those things all being looked at and worked on, but that's not a priority for us right now. The priority is take advantage of the benefits for the control plane infrastructure itself.
Thanks.
Anything else? Happy hour? All right. Thank you, guys.
Thank y'all.